Okay. So this is the factor theorem. And this is honestly what we ended with on Friday. So if we have a root or a factor that when we substitute it in, we get a 0. That's why we call our roots, our zeros, our solutions, all the same thing. So it's saying if this piece is an actual factor, we're going to get 0. That is how we have found roots and solutions of zeros for a long time. So what we're going to start with today is we're going to start with looking at polynomials and finding out if a given factor is an actual factor or if it's just a divisor. Okay, so we're trying to see if this would be 0. And we're going to use that synthetic substitution where it's the synthetic division, but we're just finding our remainder to do so. So I'm going to give us our first set of polynomials. So we're going to find our quotient and remainder if f of x is divided by p of x, and we're going to use our synthetic division. So my f of x, we've got 2x cubed minus 3x squared plus 4x minus 5. Oop. So we're going to set up our synthetic. What are my numbers that are going to go across the top? -3, 4, -5. We take just the coefficients, no letters. If we are dividing by x minus 2, what's going to go over here? Positive 2. It is the root of that, the root we would get from that, the answer. So doing our synthetic, we're going to drop it, multiply to the left. 2 times 2 gives me 4, and then we add. -3 plus 4 is 1. Bottom times the left, 2 times 1, which is 2. Put it under, and then we add. 4 plus 2, that's going to give me 6. Bottom times the left, 6 times 2, that gives me 12. And then we add. 12 plus -5 is 7. This is my remainder. So is p of x, is x minus 2 a factor of f of x? No. So we can have our quotient and our remainder, our r of x, that equals 7. If p of x is a factor, r of x equals 0. Every single time, the remainder will be 0. Because f of x equals 0. Our q of x, our quotient, the guy that would be on top if we did this long division style, is going to be what? 2x squared. It's always going down by 1 degree. Plus 1x plus 6. These are our coefficients for q of x. It always goes down 1 degree. That's why we can only do our synthetic division with our linear factors. Okay, questions on this one? We did these a lot on Friday, but I kind of will go through them again a little bit. Okay, let's do another one. Same thing. I want to know, is x minus 4 a factor of this? And we're going to figure out what our remainder is and what our quotient is if it's not a factor. So let's set up our synthetic division. What are our numbers that are going to go across the top? 3, good. 0 x to the fourths. 0 x cubes. 6x squared. 0 x's. And then 15. We can't skip terms. We have to have every single term from my constant until my biggest. We have to have them there. So even though I don't have any x to the fourths, I still need the 0. What's going to go over here? 4. It's the root that goes with this factor. All right, so let's do this. If you're working ahead and it's unpleasant, you are right. So the first one drops. 3 times 4, that's going to give me 12. And then we add. 0 plus 12 is 12. 4 times 12, we get 48. Add 0 plus 48, and we get 48. Times 4, 192. And then we add 198 times 4. It's a big one. 729 plus 0 is 729. Oh, did I dyslexia that one just a little bit? Did you say 792? Is that what it was? I was apparently very tired when I was working through my notes over the weekend because this is like the 3rd error, very similar to that I have had in my notes that I prepared over the weekend. Apparently, I was mixing up numbers. Never actually been diagnosed dyslexic or with dyscalculia, but it could happen. 792 times 4. 168. Add those together. 3,183. Ew. So, is x minus 4 a factor here? No. By a long shot. So let's put down our r of x, our remainder, and our q of x, our quotient. So my r of x is going to be just the value of our f of 4. It's that 3,183. The remainder, that last box, is our r of x. I'm going to come down here to write my q of x just because we have a lot of pieces here. What is the power for my first term here? 3x to the what? 4th. Plus my 12. And then we just go down. X cubed. Plus our 48. X squared. Plus 198. X. Plus 792. If I take that and multiply it all out by x minus 4, and I distribute that through, we will have a whole bunch of things cancel out, and we'll wind up exactly with what we had before, our f of x. So sometimes they are unpleasant. It's easier to do this way without a calculator than to do it as a long division or trying to substitute it in without a calculator. Every time. Yep, that is what our remainder theorem at the beginning said. So only if the remainder is 0 is it a factor. Okay, questions on this one? Okay. I still see a bunch of people writing, so I'm going to give you a couple more seconds to write. Minutes. I'm not going to rush you that hard. Cool. Cool. I'm just making sure we get everything we need to get to today. All right. One more like this, and then we'll move on a little bit. So we're finding our quotient, finding our remainder, saying this is a root, whatever's going on here. Setting this up as synthetic division. Ooh, it's a bit big. What are my numbers going across? 4, 0, negative 5, 0, 1. What's going on top, or top left? It's over here. 1/2. Which is fine. We can do that. It does not change the process if this is a fraction. It's exactly the same. So our 4 is still going to drop. We still take our bottom times the left. 4 times 1/2. That gives me 2. Then we add. 0 plus 2 is 2. 2 times 1/2 is 1. Negative 5 plus 1 is negative 4. Negative 4 times 1/2 is negative 2. And we add, we have negative 2. Negative 2 times 1/2 is negative 1. We add, so what's our remainder? 0. So is x minus 1/2 a factor? Yes. Our r of x equals 0. That shows that this is a factor. So let's grab our quotient real quick since we're here. What's our q of x? 4x cubed. Yes, it goes down 1 degree. Plus 2x squared minus 4x minus 2. So we found one of our roots, and what we have from here is now I have something that, if we had the information for, we could factor this. In fact, I could factor this one by grouping to be able to get this down into something that had roots. We could factor this one. I could bust this into pairs and factor out some pieces. Totally fine. We could do that. It's not what we're going to do right now, but we could. So because our r of x equals 0, that means this chunk right here is a factor. X minus 1/2 is a factor. Or you could write it as 2x minus 1 is a factor. Okay. Questions on this one? Okay, so there's a couple of strangely worded problems on the homework, so we're going to do a couple of them like that. So our first one that's really weirdly worded is this. We've got the polynomial f of x equals x cubed minus 3x squared minus kx plus 12, where k is real. All that means is you're going to find a number. And they're telling us to suppose that x plus 2 is a factor of x. So they have this polynomial, and we know x plus 2 is a factor of x. We know it. They're telling us that. Since it's a factor, since we know that, what does that tell us about the polynomial? The remainder would be 0 when we divide that out. So what is the root for this piece again? What would my negative 2? When x is negative 2, we know that the remainder is 0. That's the same thing as saying f of negative 2 is 0. Because that remainder is the same thing as that value. That was what we worked with on Friday. That our r of x is the same thing as evaluating it at that value. So since we know x minus 2 is a factor, what we're going to do is we're going to substitute those pieces in. So I'm going to take the fact that f of minus 2 equals 0, and we're going to substitute those pieces in. So we're going to set up f of negative 2. I'm going to set that piece up first. So we're substituting in our negative 2. So we're going to take our negative 2 cubed minus 3 times negative 2 squared minus k times negative 2 plus 12. What's up? I'm starting out by substituting in the x. Just like we would if we were trying to evaluate f of negative 2. But the thing is, we know what f of negative 2 equals. I know this thing's going to equal 0 because that was the definition of that root or of that factor being a factor. It's going to equal 0. So let's simplify this a bit and set it equal to 0 because we know f of negative 2 equals 0. So what is negative 2 cubed? Negative 8. What is negative 3 times negative 2 squared? Negative 12, because negative 2 squared is a positive 4. Negative 3 times positive 4 is a negative 12. Then we have minus k times minus 2. Positive 2k plus 12. So my negative 12 and my positive 12 cancel out. Add 8 to both sides. We're having 8 equals our 2k. So 4 equals k. So this one only has one value of k. So my k equals 4, 4 equals k, all that jazz. Questions on this one? Okay. So we're going to do it again. I want to practice another one because these are weird. And sometimes they get a little wilder. Good. I hope so. So now we have f of x equals kx cubed plus x squared plus kx squared x plus 3k squared plus 11. So there's a lot more pieces in here. Where k is a real number and x plus 2 is a factor of f of x. So what is our factor that we know here? -2. And since we know it's a factor, I know that f of -2 equals what? 0. That's our factor theorem. That's what that says. That by definition of being a factor, f of -2 has to equal 0. That's what we're saying that means. So when we set up our equation here, I know that 0, my f of -2, is going to happen when my x is -2. So substitute that piece in. We're going to have our k times that -2 cubed plus my -2 squared plus k squared times -2 plus 3k squared plus 11. So there's a lot more k's left this time. So let's simplify each of these as much as possible. We have our 0 equals k times -2 cubed. It's going to give me -8k plus -2 squared, which is 4. Like that one. -2 times k squared gives us minus 2k squared plus 3k squared plus 11. What should we do next? Combine some like terms. And let's put things in an order that kind of helps us out. We like to have our biggest exponent first. So I'm going to combine together my minus 2k squared and my 3k squared. It's going to give us 1k squared minus 8k plus 15. How can I figure out what k is? I heard a lot of things, but I could not tell what any of them were. Factor it. Yeah, our pair of numbers that multiplies to make 15 and adds to make -8, -5, and -3. So our factored form here is going to be k minus 5, k minus 3. So what are my values of k? So that's why it says find all values of k, because there can be more than one. There are two different equations built like this with this structure where x minus 2 is a factor. We don't have to write them out as equations. We're just finding the k. But there's more than one sometimes. So if you wind up with something being squared, factor it. Or quadratic formula. Because I know some of us like that. Okay. So there's really only one more kind of question on this homework. And it's this one. It's to find a polynomial with a leading coefficient of 1, and they'll give you some degree, they'll give you some zeros, and we'll go from there. You saying this one's too much?
Oh, no.
I was gonna say, this one is actually kind of review. Really? How would I write a factor that has a 0 of -2? X plus 2. How would I write a factor that has a root of 0? X plus 0 or just x. How would I write a factor that has a root at 5? X minus 5. What degree will this have when multiplied out? X cubed. It will have a degree of 3. So all we need to do to find our standard form equation for f of x is to multiply this out, which is what exactly we're going to do. So we're going to multiply this out, multiply it in stages. So we're going to take piece by piece. So I'm going to multiply my x plus 2 times my x first, just because it's really easy then, so that I have x squared plus 2x. And our x minus 5. And then we're going to multiply those two pieces together. We see it? Okay. So that's why I waited for a second, because sometimes all we need to do is sit and look at it for a second. What do we get when we multiply this out? We have our x cubed minus 3x squared minus 10x. That's how we find those polynomials. Let's practice one more like this, but I'm going to have to handwrite it out. Page. So let's do another one just like that, where we're going to make one that has degree 4 and has zeros, -3, 0, and we'll go plus or minus 1. That does say plus or minus 1. Sorry, I was writing it down and my handwriting went a little wonky. I'll fix it. Plus or minus 1. Well, I'm taking from the book to very similarly structure to homework questions, but not be exactly the same, just so we can make sure we practice things that we need to. So, what are my factors going to be? X plus 3. X. And then this one's going to give us two factors. X plus 1, X minus 1. So when it has a plus or minus, it's just telling you both, just in the same stack. Doesn't change anything else. Just looks like that. What degree will this have? 4. So we're in the right spot. We always need to double check it, but if we're following the roots that they give us, we should be right there. So then what we're going to do is we're going to multiply this out, because this is our f of x, but we're going to have this be in our standard form. So this is our function, but we need it fully multiplied out. So I'm going to multiply this in 2 groupings. I'm going to do this group as 1 multiplication, and I'll do my green group as 1 multiplication. So our f of x, our function, by my x plus 3 times x, it's going to give us x squared plus 3x. When I multiply these ones together, my plus or minus 1 roots, what are we going to get? Yeah, this is our difference of squares pattern. So we actually get x squared minus 1. So when we have those plus or minuses, it actually is going to be our difference of squares as a factor. So our f of x, we need to multiply this one out. Actually, I haven't pre-done this one, so we're going to have our x squared times our x squared, giving us x to the 4th. I have my 3x times x squared, giving me 3x cubed. I have my minus 1 times my x squared, giving me minus x squared. Minus 1 times 3x, giving us minus 3x. Okay, questions on this one? That's the end of section 4.2. We've got a little bit more than 5 minutes left. So we have PSET coming up on Thursday. We're going to have our first quiz in this chapter on Friday. That's over sections 4.1 and 4.2. And possibly limits. Let me see if there's limits on the quiz. So the quiz is sections 4.1, 4.2, and limits. What's up? Yeah, Tanetta. The homework one, not the packet.